Okay, what do you want?
31.
Connor?
Yeah.
31?
15.
34.
Okay.
13.
31.
Whoa, 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 whoa.
Oh, yeah.
18?
Yeah.
Okay. 18. Just like always, we're trying to find the limit. The very first thing that you try and do is what? The very first thing you try and do is what?
Plug it in.
Plug it in. So you try and plug 1 into there, and then you can't do it because you end up with a 0 on the bottom and you can't divide by 0. So the next thing you're going to do is you are going to factor and cancel. Okay? And so we had this on the board yesterday and I don't remember it. But the difference of 2 cubes is it a plus b?
No, a minus b.
Okay, it's a minus b, so this is going to be x minus 1.
A squared.
And then it's a squared, which in this case would be x squared, plus a times b, so 1 times x is x.
I thought it was minus.
It's not, plus b squared, which is 1. Okay? When it's the difference of 2 cubes,
It was on the floor,
No.
Yeah.
Yeah.
did I?
Yeah. No. Yes. No.
So if you change this to the sum of 2 cubes, this becomes a plus, and then this becomes a minus. Okay? All right, and then the bottom, Raina will tell us, is the difference of 2 squares, so that factors into x minus 1 times x plus 1. And now that you have that, you can cancel. And then since the stuff on the bottom canceled, now you can plug in 1 directly and get 3 halves or 1.5. Okay? All right. What else?
Oh, no.
34?
31.
Wait.
31 was easy.
Okay, we'll do 34 and then we can come back if we need to. Okay? Chatty today. 34. Oh yeah, use the squeeze theorem to show that.
After this, I need help with 31C.
Okay, so we're going to use the squeeze theorem to show that the limit as x approaches 0 of that crazy thing is 0. Illustrate by graphing the functions f, g, and h on the same screen.
I didn't get where there was
so this
F.
is going to be f, okay? So we need to find the function g of x and the function h of x, that where 1 is bigger than those everywhere and 1 is smaller than those everywhere, okay? So what do we want to start with? What did we start with in our little example? Right, so we can take this guy right here, and we can say that we know that the sine of pi over x is going to be less than or equal to -1 and 1, in between -1 and 1, right? Because it's a standard sine function. Yes? Okay. Then to get this function here, we're going to multiply everything by, did I write that down wrong? X cubed. So then I'm going to multiply all 3 sides by the square root of x cubed plus x squared. So this is going to be minus x cubed plus x squared is going to be less than or equal to x cubed plus x squared times the sine of pi over x, which is less than or equal to the square root of x cubed plus x squared. How does that sound? I can just wait there for a second. Okay. All right, so what that means is, yeah. Yeah, so that means that our function that's going to be below this function is g of x, which is negative square root of x cubed plus x squared. And the one that's going to be above it is positive square root of x cubed plus x squared. And so what we need to do is we need to figure out the limit as x approaches 0 of g of x we need to figure out the limit as x approaches 0 of h of x. And if those two things are the same, then that is our answer to the whole thing. And if you plug in 0 to those, you get 0 as your answer. And so that means since our original function is in between those two functions, then the limit of that is 0 as well. Okay? So let's see what that looks like graphically. The question says to show that. So we're just proving it, and so the work is your answer. Okay, 0 isn't your answer, the work is your answer. All right, so our original function was square root of x cubed plus x squared times the sine of pi over x. All right, and then the first function that we chose was negative square root of x cubed plus x squared. And the second one we chose was the positive square root of that. See what I got going on over there? Some pretty crazy things happening. All right, and then now if I, what do you think I want my window to be?
Negative 1 to 1 on the y.
Negative 1 to 1 on the y.
Right here says 1.
Because of that whole big function thing. Okay, let's take a look at that. So there's the function that we're trying to find the limit of, and you can see again that it's sort of an oscillating function, and that's why finding the limit of that directly is a problem. But oh my gosh, miracle of miracles, look what happens to the two functions that we found. Our original function is perfectly sandwiched in between those. The limit of this function is the same as the limit of that function, so it's going to be the same as the limit of the original function. Okay? It is beautiful. Math is so beautiful.
Because it's the same in every country.
Okay, what else do you help with? 31C.
You just do all 31.
No, I don't know, all of the foreign countries do
Yeah, just like
Okay, 31 for A.
I heard it on the know she was saying advanced algebra is so easy.
Who?
Renata.
Oh, good.
No, but why'd you put it?
Oh, she dropped from. No, she didn't hear.
Yeah.
No, whatever. Okay, 31A. What did you get from looking at the graph? 2/3. You guys all agree with
I
that?
put 1, but for B I got 2/3.
Okay, so 2/3 sounds good. So from the graph, if you zoom in, you get 2/3. B, if you look at the table, you get 2/3. And C, let's do it exactly. So we're trying to find the limit as x approaches 0 of x over this guy right here. Okay? So you cannot plug in 0 directly, right?
Right.
You can't plug in 0 directly because you would get 0 on the bottom. And Evan said yesterday, well, what if we get 0 over 0? Does that help? We'll deal with that situation later in this class. There's a different way to do these problems, but for now we're going to do it the fun mathy way. I guess I did think so. So what can I do with this?
Multiply by the conjugate.
Right, multiply by the complex conjugate. Anytime you see that square root thing, that is your clue that that's what you're going to
I
do.
just didn't know if I did it.
So what's the complex conjugate of the square root of 1 plus 3x minus 1?
Negative
got
1
one
minus
negative
1
product.
plus 3.
Yeah, but I don't remember it. And then she abandoned us. So remember with these that you need to make the square root negative and the regular number stays the same.
You know,
Okay? So we're not changing the -1 to a +1, we're just changing the square root.
that might have been my problem.
Probably was one of your problems at least. Okay, remember on the top,
Don't distribute.
don't distribute. And then on the bottom, if I go first times first, the square roots cancel. So that gives me negative 1 minus 3x. Remember that the negative is going to go all the way through? Yes? Okay. And then if I, oh, this doesn't look good. If I go negative times the negative, that will give me a positive square root. Negative times the positive gives me a negative square root. So those cancel. And then last times last gives me plus 1. Oh, no, I'm okay. All right, so yeah, negative 1 plus 1 cancels. And then I can cancel this x here from that x there. And so what I'm really looking for now is the limit as x approaches 0 of negative square root of 1 plus 3x minus 1 all over negative 3. And now since I don't have a variable on the bottom, I can just plug in 0. So what do I get on top? Negative 2, and on the bottom is negative 3. So that's the limit of 2/3, which is what you found by looking at the graph and looking at the table. So, oh my gosh, math works. Okay, anything else? 37 and 42?
I didn't do 35, but I think I know how now.
You know how now? How now, right now?
How now.
New York.
We and Evan quote increments of like together.
That's what you told us.
Okay. Cody said it.
Yeah, it was. And I just graphed it.
All right, 37. Easy.
Rick, where'd you get it?
It's like what? Yeah, it's like the other thing we did. It's like exactly like the other thing we did. Okay? So we're going to use the squeeze theorem.
Oh.
Okay? So we know once again that the cosine of 2x is less than or equal to 1 and also greater than or equal to negative 1. Right?
Yeah.
What am I going to multiply that all by?
What if you use squeeze theorems? Always have a
Seems like it, yeah. Yeah. So then you multiply that by x to the 4th, which maybe you could have figured that out right from the beginning without doing all this work. But as your teacher, I'm obligated to do all of this work. So one of the functions is negative x to the 4th. Another one of the functions is positive x to the 4th. Since the limit as x approaches 0 of g of x is 0, and since the limit as x approaches 0 of h of x is also 0, therefore the limit h approaches 0 of the original one is 0 also. Okay? So we're just kind of showing some work there. And if you wanted to do the graph thing again, you can see that cool little picture again where the cosine thing is all bouncing around and then the x to the 4th just kind of touches right up against it. 42.
Wow, I wrote down the wrong problem.
We okay with this?
Yeah.
All right, 42. Oh, we got an absolute value in the house. Yes, that is a problem. You got Mean Girls as the answer. Okay, so for number 42, since we have a absolute value in here, we need to break this down into two functions and consider them both separately. So I'm going to say, first of all, the limit as x approaches negative 2 from the positive side. So if I'm only considering positive values of x, then the absolute value of x just becomes x, right? So that would be 2 minus x over 2 plus x. And what would that be?
That doesn't work.
It doesn't work because it's 0 on the bottom, so what do we do with that?
It does not exist.
How do you know it doesn't exist?
I don't want it to.
Oh, you don't want it to? And so, therefore it doesn't. Okay, I would like you to write that on your AP calculus exam.
They're like, hey, that girl got.
I don't want it to exist, therefore it does not.
Isn't that logical?
100%.
I don't see any flaw.
You see no flaw in that logic?
No flaw, no flaw.
Um,
I feel like she's gonna do great things. Easy to fight us.
what's that?
Okay, wait, on a serious note.
It looks like it approaches 1. There should be a way to do this algebraically, right?
I feel like you should multiply
Can't do anything,
the
no.
bottom.
Like go backwards or something like that?
I don't know. I don't like the
I
bottom.
know that, I'll cheat here in a second so we can know. I know that sometimes they take and break these fractions up into 2 pieces. So you could rewrite this as 2 over 2 plus x minus x over 2 plus x. But that doesn't seem like that helps us, does it? Because we still can't get anything to cancel by doing that. All right, so let's go to the user's name on either side.
What if, like, they're going to be on the negative side, whatever, like, so -3, but it's still right, and going down, it's going, it's getting.
Right, but what we're saying is this, at this, it won't be.
You can't understand.
It won't be.
I know.
Okay?
Shouldn't the
All right.
x be on the bottom negative?
No, it was over 2 plus x, wasn't it?
Yeah, but if you're putting in,
No, but I'm not changing this piece at all. I'm only changing that piece there.
okay.
Okay? All right, so then now this becomes very simple. Yeah, 2 minus minus x is 2 plus x. These cancel, and my answer is 1. Okay? Yeah, absolute value, ooh, struggle, it's tricky.
52.
All right, what?
52.
52.
And then 58 and then 65.
Oh, fun. What? Is it fine?
Yeah. I'm staying here. Math is more important.
Okay.
Like historian. I'm like the least important officer.
So I was thinking, Connor, we should have another constitutional convention for our class where you can do anything. So we can
All right, you ready?
Yeah.
Okay, so we are once again dealing with the theory of relativity. This is the Lorentz Contraction formula. This expresses the length L of an object as a function of its velocity v with respect to an observer, where L sub 0 is the length of the object at rest, and c is the speed of light. And so this is another product of the theory of relativity we talked about before, that as your velocity increases, what happens to your mass?
It increases.
It increases.
Which is so confusing.
Yeah, I know it is confusing. No wonder it took someone as smart as Albert Einstein to figure it out.
How do you gain
It also says, I don't know, it also says that to the observer, the stationary observer, you appear to be smaller than you originally were as you speed up.
That's 'cause
Okay?
you're going
Don't ask me to
Going
explain
further
it.
away.
This is math
You're
class.
like
No, not like that. Okay, yeah, it isn't real. Okay, so find the limit as v approaches c from the negative side. So the
Nobody
limit-
actually ever proven it yet. So.
Haven't proven it yet? Okay.
Proven what? Has anyone actually proven that the speed of light thing is like you get bigger as you start?
I don't know. I don't think anyone's approaching the speed of light very close.
Okay, so what is the limit of this as v approaches, as your velocity approaches the speed of light from the negative side? I believe it's 0, yeah, right?
So let's say what the History Channel that said Albert Einstein.
Yeah, ancient aliens, I saw that.
Oh, there you
So that's how he knows all this stuff.
go. Okay, as v approaches c, this thing's going to get closer and closer to 1, right? 1 minus 1 is 0, square root of 0 is 0, da 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 da. And so you're getting smaller and smaller with a limit of 0, okay? Why was the left-hand limit necessary in this case? Well, I'm just thinking about the speed of light and what the deal is.
You
with
can't
that.
go above it.
Right, you can't go above, you can't approach the speed of light from the positive side because the speed of light is your maximus. 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 Yes, you.
Go watch Space.
I'm not going to try and interpret the results. I'm not a physics teacher. Like I said, talk to Mr. Weber about the Lorentz Contraction formula and the conjugate. Okay. All right, 58.
This is going to say take physics.
Show by means of an example that the limit as x approaches a
I remember we talked about this, but I couldn't think of an
of
example.
f of x plus g of x may exist, so this is going to equal some number L, even though the limit as x approaches a of f of x, doesn't exist, and the limit as x approaches that same number of g of x doesn't exist either. All right, so we have to come up with an example of this. Well, what we're going to need is we're going to need a couple of piecewise functions, okay, that both have a discontinuity right here at a.
Let's say A is 1.
Okay, so A is going to be 1. All right, so now let's come up with an f of x. And it has to be one thing if x is greater than or equal to 1, and a different thing if x is less than 1. It has to be in such a way that if you plug in 1 into these things, you get 2 different answers.
Wait, didn't we do an example?
Kind of, we talked about it, yeah, we did it with a graph, and we did it in that, yeah, but in that case, they
It had
didn't
something to
exist.
do with 4 and 2 and 3 and
Right,
1.
it did, yes. So give me an easy function.
X plus 1.
Okay, x plus 1. All right, give me a different one so then where if I plug in 1, I don't get 2 as an answer. X plus 2. What's that? You okay? All right, so that's going to be our f of x, okay? So just to keep track of this, in this one here, the limit as x approaches 1 from the negative side would be what?
Uh,
2. Oh,
No,
yeah,
3.
3, sorry, 3. Because this would be approaching x from the negative side, so you plug in 1 there, and I kind of wrote that in the opposite order, yeah, that you're used to. And then the limit as x approaches 1 from the positive side would be 2, okay? So now if we can come up with a g of x that flips that around, so that when x approaches 1 from the positive side, it equals 3, and when x approaches 1 from the negative side, it equals 2. These two will add up to the same number. These two will add up to the same number, and our answer will be 5. Okay, just for example. So can you give me a function whose limit is, and I wrote this backwards, I'm sorry, usually you do the less than on top and then the greater on the bottom, but I'm going to do it wrong again just to stay consistent. Okay? I'm going to be wrong once, I'm going to be wrong all day, okay? So now give me a function so that if I plug in 1, I get 3 as an answer.
X plus
4 minus,
Do I want 2? Because I'm confused because I'm backwards.
No.
This is 1 from the negative side, this is 1 from the positive side.
So you want 3. You want 2.
So you want 2?
4 minus 2x.
I want 3, right. Yeah, I want 3 because this is approaching 1 from the positive side and this is approaching 1 from the positive side. So if I want this to be 2, I need it to be 3. So it's what? 4 minus x. Okay? And then,
No, we want. Oh, okay.
yeah, I wrote the limits opposite of those. Yeah. So I'm really messing with your mind. Okay? So now I need one that equals 2.
3 minus x.
3 minus x. Okay, so now if I look at the limit as, it is way too much, as x approaches 1 from the negative side of g of x, So sorry, from the negative side, that's this one down here. What do I get?
3, 2.
2, because I plug it into
It
here.
looks like X4.
Yeah.
Okay. Okay, and then if I look at the limit as x approaches 1 from the positive side of g of x, then I get 3. Okay, so now if I look at the left-hand limit, the limit as x approaches 1 from the negative side of f of x plus g of x would be 5. If I look at the right-hand limit, the limit as x approaches 1 from the positive side of these two added together is also 5. So that means in this thing back here, this whole thing would equal 5. But the limit of these two functions as x approaches 1, since you have different answers for those, does not exist. Okay? Okay, does that make actual sense?
Yeah.
Okay, good. I'm sure all the people watching at home are going, what? What was that thing about aliens and Albert Einstein? And who is ever going to the dance with?
You're gonna know our lives. Like,
Yeah, some random person could just stand and be like, oh yeah, I know you.
Oh, you go
You're
with
gonna like friends with us.
You Bailey?
Random people.
You go to Bailey, but you're talking to other people named Jenna?
Which one am I doing now?
61.
61.
Yeah, we used to do that.
What was that?
I'm really getting tired of writing the whole limit thing.
Yeah, I don't
Really
like
grinds
that.
my gears.
Okay, is there a number A such that that whole thing exists? If so, find the value of A and the
should
value of
factor
the
the
limit.
bottom.
Okay, let's factor the
Wait,
bottom.
where's the Why don't we try the thing where you plug it in?
Okay, let's try the thing where you plug it in. Guess what?
Oh, yeah. never
0 on
mind.
the bottom. All right, so if we factor the bottom, we get x and x minus, no, plus 2 minus 1. Okay? All right, so the problem is that it's this x plus 2 thing, right? Yes? So we need to rewrite the top in a way that it has a factor of x plus 2. And the question is, what would be left if we did that? Okay? So the way that we're going to figure that out, I think, is we're going to do a little synthetic division.
Oh, good idea.
So hopefully it'll work. So this is going to be 3. This is going to be A. And be careful with this. This A plus 3 is my entire constant number. Okay, it's not two separate values. That's my constant. Okay, so bring down the 3. That gives me -6. A and -6 is A-6. Multiply that by -2 and you get -2A plus 12. Add those two things together and you get -A plus 15. Okay, did I do that right?
I don't really use calculus for this or
I know, I apologize. That's actually his fault. The books all do it this way, so I don't know where he was in that.
I don't.
Right. Okay, so what did I want this answer to be?
0.
0. So what does A have to equal for that answer to be 0? 15. Okay, so if A is 15, then this would factor into, what did we start with, x squared, so this would be 3x plus 9. Oh, and then we're done because we have it squared, sorry. Okay. And my original equation would be 3x squared plus 15x plus 18, right? Does this factor into that? 6, 9, yeah, so that would work. Okay, so are we okay with that? All right, so now we can evaluate the limit because in this case those will
But
cancel.
we don't need to.
Yeah, it says, and then figure out what the limit is. So then if you plug in -2, which we can do now, you get -6 plus 9 is 3 over -3, which is Do the easy part wrong. Alright, okay, we alright? Okay, what time did I say we get out?
Wait, hold on. What? Yeah, 29.
Oh, 49.
Yeah.
What about?
I think I got them. Can't be sure though.
The B and C part.
The B and C part?
Yeah, because I just did 2 for all of them.
Oh, right, so what's the answer to B?
N.
If you're approaching n from the negative side, then it's what? It's n minus 1 because you would be on the step below, right?
Or N plus 2.
No, then if you approach n from the positive side, it'll just be n because you're on that actual step.
I didn't say whoa.
Does that kind of make sense? Are we going to show that?
No.
I'm asking Leanne not. Do you want me to show you what I'm talking about there?
No, I think it's fine.
It's like the step.
Well, I can't, if I approach it from the negative side, I think it's just N.
Because the step function looks like this. The open circles are on the
Right.
right. Okay. So it looks like this, open circle, this, open circle, this, open circle. Okay, so if this is n, if you approach this from the left-hand side, then your answer is going to be 1 lower.
Oh,
Okay, and if you approach it from the right-hand side, then you're on the same thing.
and then what values
For what values of a does the limit as x approaches a of the absolute part of the thing exist? All non-integer values. Because at every integer there's a break in the graph, and the left-hand limit is different from the right-hand limit.
It's not all
All non-integer values.
Do you remember that time when we were at Kate's house all those times when we would serve fries?
In the time that he used to be the rules.
Oh,